All right, hello, this is 18E, Rules for Integration. And on page 457, you'll see a big list of some functions and their derivatives. And you're familiar with all those because, of course, we already know them. You might notice that the IB uses a little different notation, like, for instance, e to the f, they say the derivative of e to the f of x is e to the f of x times f prime of x. Whereas we had said the derivative of e to the u is e to the u times du. So just slightly different notation, but all of those should look familiar to you. And then our goal for integration is to find the antiderivative. So that would be like, for instance, if I had this, if I said the integral of e to the u du would be e to the u. So you're going backwards. The integral of e to the u du would be e to the u. Plus c, actually. So let's just go ahead and talk about some of the rules for integration. Well, okay, so these are some of the rules. The first one is the integral of a constant with respect to x. And we already talked about that in a previous section, that that's going to be kx plus c. Because if you took the derivative of kx plus c, you would get x. Or k, k. And then the integral of x to the n dx, I've already talked about that one as well. That's x to the n plus 1 divided by n plus 1 plus c. So that's the power rule for integration, and n cannot equal negative 1. So if n did equal negative 1, so that'd be the integral of x to the negative 1 dx, it has its own formula. If I rewrite that in the form integral of 1 over x dx, then that might look a little more familiar to you. Can you think of a function whose derivative is 1 over x? And that function would be the natural log of x. And we have to write it, though, as the natural log of the absolute value of x, because the domain of, so natural log looks like this. You can't take the natural log of a negative number. So the domain of natural log is x greater than 0. So we have to put the absolute value bar around x. And then, oh yeah, I just talked about this one, the integral of e. Now, the IB book has it written like so, which is true, but we can go one step further, and let's do e to the kx dx, because oftentimes that's what you'll have. And if you, so say the integral, you said it was well, let's do an example, I think it's easiest. Say you did e to the 3x, and you were trying to find the integral, which means the function whose derivative is e to the 3x. So let's say you just said it was e to the 3x. Well, if you go backwards and differentiate, well, e to the 3x plus c. If you went backwards and differentiated this, you would get e to the u times du plus c. Or no, that would be plus 0. My goodness, I need to wake up. That'd be plus 0, because the derivative of a constant is 0. And you can see that the original one was e to the 3x, not 3e to the 3x. So in order to make it match the original one, we would have to divide this by 3. So the rule for e to the kx dx is e to the sorry, e to the kx divided by k plus c. So this one's a little more helpful than the one that they have in the book. Then the integral of cosine. of x dx. So you're asking yourself, we need a function whose derivative is cosine, and that would be sine of x plus c. The integral of sine of x dx. A function whose derivative is sine would be cosine, but the derivative of cosine is actually negative sine, so we have to put a negative on there. Great, so those are some integral formulas, and of course they're all in the book as well. And now we can do some examples. I recommend that you memorize these because, I mean, it's easy enough to remember them, and if you have them memorized, then you've got them handy when you need them. So this is example 7. Integral of x cubed minus 2x squared plus 5 dx. The first thing you need to do is recognize what sort of situation you have here, and this is a polynomial, so we are going to just use the power rule, and that means I'm going to be adding 1 to the exponent and then dividing by the new exponent. So 3 plus 1 is 4, and then you divide by that new exponent 4. Minus 2. The 2 is a constant, so you can just write down minus 2, and then find the integral of x squared. So add 1 to the power and divide by the new power. Plus, and then the integral of a constant is 5. In this case, it will be 5x. And then plus c. Make sure you add the plus c, because this is an indefinite integral. So it's a family of functions. It's a family of all these functions that differ by c. Next, let's go to a new page. So this is example 7, part B. Find the integral of 1 over x cubed minus root x dx. This one's obviously a little more difficult. And what we're going to want to do here, we can't use the power rule yet. What we can do though is we can rewrite these so that we can use the power rule. So 1 over x to the third is the same as x to the negative third, minus, and then the square root of x is x to the 1/2 dx. Please stay in the habit of bringing down your notation, your integral sign, and your dx, because your work is like a proof. So just keep following along there. And then you're going to, now we can use the power rule, so we can add 1 to the exponent. So negative 3 plus 1 would be negative 2, divided by the new exponent. Minus just comes down. And then add 1 to 1/2, and you get 3/2. And then you have to divide by 3/2, which is the same as multiplying by the reciprocal 2/3. And then plus c. You can leave it in this form. You could also rewrite it. I've noticed sometimes in the IB book they rewrite it and sometimes they leave it. So I'm going to rewrite it just in case. You need to know that. Like, what if it, well, they don't do multiple choice, but anyway, just in case you need to know. So it is good practice to bring down the x squared and put it, so you have negative 2 there, and then x squared minus 2/3. And then you sometimes will see them write x to the 3/2 as, think of it as x to the 1/2 times x to the 2/2, because then that 1/2 plus 2/2 would be 3/2. And then x to the 1/2 is the square root of x, and x to the 2 over 2 is x to the 1, or just x. So sometimes you'll see them write it like that, and then plus c. So either one of those, like on this first one, I would bring down this x to the negative 2 and write it this way. That's good practice there. Next is example 8. Integrate with respect to x, it says. So instead of writing the integral symbol, they're just stating it in words. Letter A. So I'm going to go ahead and write the integral of 2 sine of x minus cosine x dx. And if you want, you could put parentheses around that. Well, this one, we can just work our way across and integrate it. The 2 is a constant, so you can just bring it down. And then the integral sign is negative cosine. Bring down the minus. The integral of cosine is sine, because the derivative of sine is just cosine. And then plus c. And that one doesn't require any simplifying. Letter B, I'll squish it on this page. We've got the integral. It doesn't say the integral, but they're asking us to integrate, so I'll go ahead and put it in the correct notation. And this first one, you might notice that it's essentially saying negative 2. What I'm going to do is pull out the negative 2. I'm going to rewrite this integral a little bit. I'm going to pull out the negative 2 and rewrite it as integral of 1 over x dx. And then I'll bring along the integral sign. I'm going to write plus, and then I'm going to pull the 3 out of the next one. So I'm using that sum property to break this integral into 2 integrals. And I'm also using the constant property where you can pull the constant out front. Now I realize when you're doing these and you get good at them, you don't need to rewrite it. You can kind of do it in your head. But anyway, so now it should look a little more familiar to you. This is the integral of dx over x, and in this case it's actually natural log of x. So you have negative 2, and then the integral will be natural log of x in absolute value bars, plus, and then the 3 is a constant, it comes along. The integral of e to the x dx is e to the x, and then plus c. And that's all nicely simplified. Which brings us to example 9. Integral, this is letter A, of 3x plus 2 over x, all that squared dx. Okay, this one, what you have to do is there's no way to integrate it the way it's written, so what you have to do is you have to square, like FOIL this out. Like so. So I'm going to have the integral of 9x squared. The outers are going to be 6, because those x's will cancel, and then the inners are also going to be 6. And the last will be 4 over x squared. So I'm going to combine like terms. And now I've got it in a form that I can integrate. So the integral of 9x squared would be 9x, add 1, so 3, and then divide by the new power, plus this is 12x. And then this is the same as 4 times x to the negative 2. So bring along the 4, and then you'll add 1 to the power and divide by the new power, and then plus c. So you do want to go back and simplify a little bit. This is going to be 3x cubed plus 12x minus 4 over x is a nice way to write that, plus c. And let's see, there isn't also a part B on this example, so that concludes that one. And then we'll do example 9, part B. Different problem. Integral of x squared minus 2 all over root x dx. Okay, this one also has to be rewritten. We cannot integrate it the way it's written. So anytime you have either a plus b over another term or a minus b over a term, you can break it into 2 fractions, like a over c plus b over c, or a over c minus b over c. So that's what we'll be doing here. So this will be the integral of x squared over root x minus 2 over root x dx. So I'm breaking it into 2 fractions. Then I can simplify these a little bit. You can't integrate them yet the way they're written. So this is x squared over x to the 1/2. So that's going to be x to the 3/2. 2 minus 1/2 is 3/2. minus, and then that's going to be bringing that root x up to the top, so you're going to have x to the negative 1/2. And then now it's in a form we can integrate by using the power rule. So add 1, that's going to be 5/2, and then divide by or multiply by the reciprocal, 2/5. Bring along the minus 2. Add 1 to 1/2 and you get 1/2, and then we're going to divide by 1/2, which is the same as multiplying by the reciprocal of 2, and then plus c. So, well, you could write it like so. Or you can also write it the way, so I'm checking to see how the IB, oh yeah, so this time they did rewrite this using the radicals. So x to the 5/2 is the same as x to the 4/2 times x to the 1/2. X to the 4/2 is x squared, and then x to the 1/2 is root x, minus 4 times root x plus c. This other way is also acceptable, but it is good if you can write them in either form. Now we're moving along, so that's section E.1, and now we're going to do section E.2. There are 3 examples in this section as well. Example 10 is the first one. Find f of x given that f prime of x is x cubed minus 2x squared plus 3, and f of 0 is 2. So what we're going to be doing, these are called finding the particular solutions. They're giving you the derivative and they want you to find f. So that means if you want to go from the derivative to f, you have to find the antiderivative, or you have to integrate. So you're going to, because the integral of the derivative is f. So I'm going to be doing the integral of x cubed minus 2x squared plus 3. And this is a indefinite integral because there's no limits. Okay, so we'll go ahead and do that. That's going to be x to the 4th over 4 minus 2x to the 3rd over 3 plus 3x plus c. And that equals f of x. Okay, that's a general solution because it's plus c. Now we're going to find the particular solution because we have this initial condition right here. We have this additional bit of information that when x is 0, y is 2. That's what that's saying. When x is 0, y is 2. So we can plug in 0 for x and 2 for y. So y is the f of x, so 2 equals, and then plugging in 0, of course I realize you're going to probably do this in your head, plus c. So all of these are going to go to 0. 0, 0, go to 0. And you end up with 2 equals c. So now you come back and you rewrite the final result. F of x equals x to the 4th over 4 minus 2/3 x cubed plus 3x plus 2. And this is the particular solution for this given condition. Now, it doesn't always happen that the c, it doesn't, just because you plugged in 0, and like in this case, f of 0 was 2, and you notice the c was also, also 2. That's not always the case. You can't always assume that. You have to handle these on a case-by-case basis. Example 11. Find f of x once again, given that f prime of x is 2 sine of x minus root x. And the initial condition is f of 0 equals 4. Okay, so once again we're given the derivative. We have to find the antiderivative, or the integral, in order to find f. So f is going to be the integral of the derivative, 2 sine of x minus root x dx. Okay, so f of x will equal, it is good for you to bring down that f of x. The integral of sine is negative cosine. And then this is x to the 1/2, so then there's a minus there. So add 1, that's going to be 3/2, divide by, or multiply by the reciprocal, 2/3, and then plus c. Then we have our initial condition. When x is 0, y is 4. So I'm plugging in 4 for f of x. Negative 2 cosine of 0 minus 2/3 times 0 to the 3/2 plus c. Okay, are both of these terms automatically 0? You have to be careful here. This problem has gotten more than one student in the past. Yeah, this one right here is going to go to 0, but cosine of 0 is 1. So it's actually negative 2 times 1 plus c. So that means that c is 6. So this is one of those ones, make sure you go ahead and plug the 0 in and be careful and pay attention to get the correct values. So then the final answer, f of x equals negative 2 cosine x minus 2/3 x to the 3/2 plus 6. And now we have one more example, which is example 12. This one says, again, find f of x. But this time they give you the second derivative. That's an equals 12x squared minus 4. And they give you two initial conditions. F prime of 0 equals negative 1, and f of 1 equals 4. If they want you to find f, they have to give, and you're starting from the second derivative, they need to give you more than just one initial condition. Okay, so the integral of the second derivative will give us the first derivative. So that's where we're going to start. We're going to find the first derivative first. So I'm going to integrate 12x squared minus 4 dx. That's going to be 12x, add 1, divide by the new, minus 4x, plus c. So that's 4x cubed minus 4x plus c equals f of it, f prime of x, by the way. That's why it's important to label these so that you don't get lost. Now, use the initial condition. We know that f prime of 0 is negative 1. So that means f prime is negative 1 when x is 0. So I'm plugging in 0 wherever I have an x. And in this case, c will be negative 1. So then I could come back and put my negative 1 in for c and write down my equation for f prime. Okay, there's f prime. Now I can repeat the process again, integrate that to get f, and then use the last initial condition. So let's change to a new color. Now I'm going to integrate, so f will be the integral of f prime. So I'm going to integrate 4x cubed minus 4x minus 1 dx. And that will give us f of x. So that's going to be, well, it's basically going to be x to the 4th, because you'll be dividing by 4 and there's a 4 out front. Minus, and this will be 4x squared over 2 minus x plus c. So when we have f of 1 equals 4, so 4 equals, I'm plugging in 1 for x. Oh, that doesn't look very good. Whoops, fix that a little bit. Okay, plugging in 1 for x minus, this is 2 times 1 squared. Whoops, that's a minus. I think I'm going too fast. Minus 1 plus c. So 4 equals 1 minus 2 minus 1 plus c. So we've got negative 2 there. Add 2 to both sides, we get 6. c is 6. Then I can come back, I'll just go way up above here where I have some space to write. That means that f of x is x to the 4th minus 2x squared minus x, and plus 6, plus c, which is 6. So we applied that process twice in order to get our f. And in the homework, the very last problem on E2, number 3D, it's kind of optional. It's for fun. It's a challenge to see if you can figure that out using what you know. So we'll see you next time.